this is an important note about how to think about vectors. Okay. So you're all familiar with vectors. It's sometimes convenient to think of vectors as three numbers. I don't know. Uh, if you have some velocity, vx, vy, vz, right? Uh, do not think of vectors as three numbers, okay? As sets of three numbers. Now we are talking about vectors in 3D. Nevertheless, you should not think of vectors as sets of three numbers. Instead, and this may sort of seem, if you're not used to this, instead, think of it as an object that satisfies certain properties. If you want to know what those properties are, they're properties of vector space in linear algebra. Sort of abstract vector space in linear algebra. More importantly, you should think of it as a direction and a magnitude. If you want to sort of have a direct, if you want to have a sort of geometric picture. So what does this all mean? A vector is just a vector. Like it is not a set of three numbers. A vector is not a set of three numbers. It becomes a set of three numbers once you decide to represent it in a particular coordinate frame. Okay, so vector. So imagine an arrow in space that's pointing in some direction and has some length. That's what you would call a vector in our sense. But if you want to represent that arrow in a particular coordinate frame, then you can choose to use three numbers to represent them. And depending on what coordinate frame you choose to use, you will have three different numbers, right? So let's take a couple of different coordinate frames. This all may seem obvious, but let's just use this. Let's say this is one coordinate frame. Right, so this is some coordinate frame 1, and maybe there's a different coordinate frame 2. This is frame 2, and the same vector v could be written as vx1 ex1 plus vx2 ex2 plus vx3 ex3. In other words, we can represent it in this frame, right? So these are the components of the let's say v is some velocity vector. These are the components of the velocity vector in these three directions. Now we can also say v equals, let's say, vx2 ex2 plus vy2 ey2 plus vz2 e z2. Now I meant here y1 z1. Okay, anyway, so we're representing v in this frame and this frame. Now, of course, if you think of velocities as or this vector has three numbers, well, is it this three numbers or this three numbers? Of course, it depends on what representation you're using. So we might say this set of three numbers is a set of three numbers representing v in the coordinate frame one. Similarly, vx2, vy2, vz2 is a set of three numbers representing v in the coordinate frame 2. So this is a representation. This is not the vector itself. This is a representation, okay? So it's not the vector itself, but the representation of the vector in a particular frame, right? That's very important. So that's what I meant by saying a vector is not a set of three numbers. The three numbers is a representation of a vector in a particular coordinate frame. So what we might do, I'm going to introduce a piece of notation. So for representations like this, we might say this thing is actually equal to v, the vector, but it's not equal to v itself, but we're going to say it's the representation of v in the frame, well, I want to say 1, okay? I want to say frame 1. So what we are saying here is that this is not equal to the vector itself, but it's actually the representation by enclosing it in square brackets in frame 1 is what we are saying. So of course, given two such representations, we do have these two are equal, of course, right? So these two are equal quantities. As a vector, they are equal quantities because they both are just two different representations of the same vector. So that's fine. Okay, so that's a very important concept.